Okay, so this is section 10.3, video number 2. In video number 1, we kind of developed the idea of how polar coordinates are defined. So now we're going to be able to take either a polar coordinate and put it into rectangular form, or put a rectangular coordinate in polar form. This is actually something which is much more important when you get into Calc 3, because the coordinate systems get a little bit bigger and more involved, but still important for this particular unit as well. And again, remember the idea is we're taking a radius and an angle to get to some point in space, as opposed to an x and a y coordinate. So there's a couple of conversion factors. If I want to go from polar to rectangular, there's two nice easy formulas to use. X equals r cosine theta and y equals r sine theta. R sine theta. Okay, and the way that that's developed is basically from a circle, a unit circle idea. I'll give that to you real quick. So there's our circle, and if I were to create on our circle here, let's try and, that's not so bad. If I were just to create a triangle, there is a point right there. Okay, again, normally we'd be used to going in x and y coordinates, which is going to be some kind of an x distance, some kind of a y distance, which you can see creates a right angle or a rectangular coordinate. But the other way to do it is to use the radius, which is the distance from the origin out to the point, and the angle in between. And the reason that we have the x equals r cosine theta and y equals r sine theta basically comes from old geometry. If you take the angle to be the angle that I labeled, the opposite side is this side over here. The adjacent side is the one down here. And hopefully you all remember that sine is opposite over hypotenuse. So sine is opposite, which is nothing more than a y value, over the hypotenuse, r. Well, if you multiply both sides by r, then you get that r sine of theta equals y. And I'm not going to show it for the x, but it's exactly the same idea. So that's how you get those formulas. All right, but this is by far the easier way to convert. So if I am given some kind of a point in polar, which they did give me an example for, I can put it into rectangular by using those two formulas. So let's do that. X is going to be r. Remember that this is r theta. That is always the way it's going to be. So r is -3, and theta is going to be pi, so it's going to be x is cosine of pi. And then y is going to be -3 because it's r sine theta, so sine of pi. So again, you just kind of have to know your trig values here. Well, let's see. So cosine of pi is -1. -1 times -3 is +3. Sine of pi is 0, so 0 times -3 is 0. So that is the point in rectangular coordinates, 3, 0. And if you think about that, that should make sense. An angle of pi would go that direction, but it would have to go -3 units, which is 3 units in the other direction, so out here. So that would put me right there, which is going to be the point 3, 0. So we've converted from polar to rectangular. Okay, let's try another one. Example 5, convert the point 7, 4 pi thirds from polar to rectangular. So again, x is r cosine theta. So r is 7, cosine of theta, cosine of 4 pi thirds. Y is r sine theta. So 7 sine of 4 pi thirds. So again, we just have to know our trig. 4 pi thirds is going to be in the third quadrant, so both cosine and sine are negative. Cosine of 4 pi thirds is going to be -1/2, so times 7 is -7/2. Sine of 4 pi thirds is going to be -√3/2, so we're going to get -7√3/2. So our rectangular coordinate is -7/2, -7√3/2. Now, if this one doesn't tell you, because I'm sure the question has come up, well, why would I want to plot these things in polar coordinates? Imagine trying to graph -7/2 and -7√3/2 exactly on a rectangular coordinate. Not easy to do. But graphing 7 and 4π3 in a polar coordinate system is very easy to do, because 4π3 is a normal angle on a unit circle, and 7 units is really easy to figure out using concentric circles from the origin. So that's a much easier way to plot these points. And a lot of times when you're dealing with things that are circular in nature, or deal with trig functions, then polar a lot of times is going to be the easier way to graph points. So for the people who were asking that question, because I'm sure it's crossed some of your minds. All right, we can go backwards. We can convert a point from rectangular to polar. Similar idea. It all stems from the triangle, but you need to find a way to find r and theta if you're given x and y. Well, if you use the Pythagorean theorem, x squared plus y squared equals r squared, and again, that stems from that right triangle that we created in the circle, then you can find r, because you'll be given x and y, solve for r. And you can also use, you could actually use several of the different trig functions here, but tangent's the easiest one to use because it involves the opposite and adjacent side, which is a y and an x. So tangent of theta is y over x, and you can use that to find theta. So let's go ahead and do an example. All right, so example 6 says, convert the point 4, -4 from rectangular to polar coordinates. Easiest thing once you're given x and y is to find the r value. So that's going to be x squared plus y squared equals r squared. Well, x squared is 16. Y squared is also 16. And that equals r squared. So we get 32 equals r squared. Now, if we have to do this exactly, then we're just going to make 32 2 times 16 when we take the square root. So we're going to do the square root of 2 times 16 equals the positive or negative r. And the square root of 2 is not something simplifiable easily, so we'll just do the square root of 16, and we get 4 root 2 plus or minus equals our r. Okay, now we want to go ahead and find the theta. So we're going to do tangent of theta is y over x, so -4 over 4, which means that tangent of theta is -1. So now you just have to kind of know, again, you have to know your unit circle values, what angle of theta is going to make tangent -1. Well, there's 2 of them within a typical one circle. One of those is going to be at 3π over 4. And the other one, which is in the 4th quadrant, is going to be at 7π over 4. So the question is, what do I use here? I've got a bunch of different things going on here. Well, this is where you kind of have to go back to the original point. The original point in rectangular was given as 4, -4. That's a +4 in the x direction, -4 in the y direction, which puts us squarely in the 4th quadrant. So you need to use what's going to get you to the 4th quadrant. Well, the easiest thing to see is that 7π over 4 is already in the 4th quadrant. So when it goes back to our radius, because you notice our radius has a positive or negative, we're going to use the positive radius that goes with that 7π over 4. So one of our points, or our point that we're going to use is going to be, again, it's r theta. So it's going to be 4 root 2, 7π over 4. But that is not the only way we can write this. There are several different ways to get to the same place. I could use 3π over 4, which is not in the 4th quadrant, it's in the 2nd quadrant, but I could use the negative radius to get to the same spot. So I could write this as -4 root 2, 3π over 4. Okay, that's probably the easiest 2 methods to do it. There are an infinite number of ways, to get to that same point, because you could technically keep going around the circle to different angles and just keep flip-flopping whether you're going to use positive or negative radii to get there. But those are probably the 2 easiest ones to use. So you just have to know which ones are going to go with which based upon the original point. You have to kind of figure out what quadrant that was in and how to figure it out. Okay, number 7, convert the point -1 √3 from rectangular to polar coordinates. So again, the easiest thing to find is the r value first. -1 squared is 1. √3 squared is going to be 3, and that equals r squared. So 4 equals r squared. So r is going to equal the positive or -2. Let's figure out the theta value. So tangent of theta is y over x over -1, just means it's going to become a -√3. So then again, using our unit circle, there's going to be 2 places where this is going to occur. One of them is at 2 pi over 3. The other one, because again, 4th quadrant for negative, is going to be 5 pi over 3. Now we just have to figure out which place this should be. Well, the original coordinate is a -x and a positive y, which puts us into the 2nd quadrant. So if we want to use the standard one, 2 pi over 3 is going to be our theta value. That's already in the 2nd quadrant, so we'll use the +2 as its r value. If we want to go the other direction, we can use 5 pi over 3 as our theta, which means that you have to have a -2 angle in order to get there. All right, again, hopefully that makes sense to your thinking and your thought process on that. All right, that's how to transform coordinates. We can also do this with equations. Okay, these are not as easy because they take a little bit of algebra, but it's the same principle. So I can convert the equation x equals 2 into polar coordinates. Right now it's just x equals 2. It's only got x's or y's in it, so it's rectangular. And x equals 2, if you think about it, is a vertical line, right, going through x equals 2. This is not difficult to transform into polar. When you transform from rectangular into polar, all you can have left are r's and thetas, no x's and y's anymore. Doesn't have to have both r and theta, but you've got to only have a combination of those. So the easiest thing to think of is, well, how can I transform this? Well, x, we already know from a couple pages ago, is r cosine theta. So I am literally just going to replace x with r cosine theta equals 2. That is now in polar coordinates. If possible, we like to solve for r. It makes it a lot easier to be able to, plug into a calculator and graph it and all that kind of stuff. So if it's possible, go ahead and solve for r, simplify. So you divide both sides by cosine of theta. But cosine of theta in the denominator is the same thing as the reciprocal of secant. So 2 over cosine theta is exactly the same thing as 2 times secant theta. So r equals 2 secant theta would be the equation in probably its simplest form in polar. Okay. All right, number 9, same idea. Write the equation in polar coordinates. So I've got 2xy equals 1. Okay, the easiest thing to do might be just to go ahead and divide both sides by 2 first. So all I have left on the left-hand side is xy, although it's not necessary. But now I can replace x with r cosine theta, and I can replace y with r sine theta. And again, I'm trying to solve for r. So multiplying all this stuff together, you're going to get r squared times cosine times sine, but I need to get rid of those. So let's divide both sides by cosine and sine. So we'll get times 1 over cosine times 1 over sine. That's dividing both sides by cosine and sine. Okay, I wrote it like that for a reason. It'll just be easier to see what's going to happen. So r squared is going to be 1/2. 1 over cosine is secant. 1 over sine is cosecant. And then if I want to solve for r, we could take the square root on both sides. in this case, it's probably just better to leave it as r squared. If you have to plug this into a calculator, you take the square root. Just remember, you'd have to do the plus and the minus on both sides of the square root. All right, one more of those. Write the equation in polar coordinates. Multiple ways you could do this. I think it might be easy enough just to go ahead and do direct substitution right away. You could distribute the y minus 2 squared out if you really want to. Probably easy enough just to go ahead and do the substitution. So we're going to do r cosine of theta squared plus r sine of theta minus 2 squared equals 4. Now from here, you still are going to have to distribute everything through in that parentheses out to simplify this, but technically it's in polar coordinates at this point, so we have at least done that. So let's go ahead and square all this stuff. So that's going to be r squared cosine squared theta. The one on the second parentheses we have to distribute out, so that's going to be r squared sine squared theta. Multiplying the two terms on the inside and doubling them is going to give us the middle term. So that's going to be negative 4r sine theta. And then squaring that last term is going to give me 4 equals 4. Okay, if I want to start solving this, well, I can subtract 4 on both sides. That's nice. So I get r squared cosine squared theta, r squared sine squared theta, minus 4r sine of theta equals 0. Okay, one of the things that makes this easier to do is that you have to notice that the combination right here, r squared cosine squared plus r squared sine squared, if I factor out just the r squared, that leaves me with cosine squared theta plus sine squared theta, which is one of our nice special identities, which is kind of the most important one to know. Cosine squared of an angle plus sine squared of the same angle is 1. So that leaves me with r squared minus 4r sine theta equals 0. I'm going to go ahead and add the 4r sine theta to both sides. And then we're going to divide both sides by r to solve this. So that's going to give me r equals 4 sine theta. And you might ask yourself, well, why am I allowed to divide out an r? Well, in this case, you're not losing a value of r since r is only one value. R can only be one value for this. So it's okay to do that. Unlike solving equations like if you had x squared equals x. If you divide x on both sides, you're potentially losing a value there. It doesn't work that way in polar, so it's okay to do that. Okay. And the last page, we can go the other direction. So now we can take an equation in rectangular coordinates from polar. We're going to start in polar and we're going to take it into rectangular coordinates. The first one is very, very simple. If you recognize that r sine theta is just y, let's replace r sine theta with y. So we get y equals 4. Okay, that is now in rectangular coordinates, piece of cake. Number 12, all it gave us was theta. But remember, we do have an equation or expression that says that tangent of our angle is y over x. Well, they gave me the angle. It's 1/3 of pi, or pi thirds is probably the easier way to write that. So I'm just going to substitute that in for theta. Tangent of pi thirds is a number. It's just a value. Tangent of pi thirds is √3. So now all I've got is √3 equals y over x. That is now in rectangular form. Multiplying both sides by x, you get that y equals x times √3, or √3 times x. So √3 is really just nothing more than a slope. And that really should make sense if you think about it. Theta equals pi thirds. Theta is not changing. Your angle is not changing. This is just a linear function. And y equals √3 times x is a linear function. So if you think about that, it really does make sense. All right, I realize this video is lasting a little longer than I thought, but we are almost done. The last one, write an equation in rectangular coordinates. If you really want to challenge yourself, try and figure this one out on your own. So pause it and see if you can work it out. If not, here we go. R equals 3 cosine theta. You might think, well, let's divide both sides by cosine theta. That's fine, except then you get R over cosine theta. That's not R cosine theta. Can't just substitute an x in there. But this is what we can do. Basic property of algebra. What we do to one side, we do the same thing to the other side. We can multiply both sides by R, which is going to give me the equation R squared equals 3R cosine theta. Now this is going to be a real easy transformation because R squared, we should know, is x squared plus y squared. And R cosine theta right here is x. That is now in rectangular. Okay, you can go through a whole bunch of stuff here to try and simplify. You can complete the square and all this kind of other stuff. But we don't have to do that. This does work out to be an elliptical form of, I'm sorry, not an elliptical form. This is a square. It is a circle, excuse me again, that's just been shifted. That's all. So there you go. It is now in rectangular form. All right, plenty long enough for that video. I think we are good, and 10.4 will do all the calculus. That will definitely be multiple videos, multiple days.